Section 7.3. Our objective today is I can state and apply properties of similar polygons. Similar figures are figures with the same shape but not necessarily the same size. Same shape but not necessarily the same size. Okay? So when we talk about similar polygons, we say that they are similar if their vertices can be paired so that corresponding angles are congruent. And corresponding sides are in proportion. Okay, so if I, for example, if I have this polygon, we're going to call it polygon A, B, C, D, E. And I have a similar polygon where this is G, F, J, I, and H. Okay? So if polygon A, B, C, D, E is similar, we use this little squiggly line to represent similar, or to represent the word similar, is similar to polygon, whoops, I ran out of room here. Let me move this, okay? So let me write it below. Polygon A, B, C, D, E is similar to polygon F, G, H, I, J. Then that means that A corresponds to F. So angle A is congruent to angle F. B corresponds to G. So angle B is congruent to angle G. Angle C corresponds to angle H. So C is congruent to H. And angle D corresponds to angle I, so they have to be congruent. And angle E corresponds to angle J, so they must be congruent. And their sides must be in proportion. So AB is to FG as BC is to GH, as CD is to HI, as DE is to IJ, as AE is to FJ. Okay, so this is to this, as this is to this, okay, as BC is to GH, okay, and so this corresponds to this, and this corresponds to this. Okay, so so they have to be in proportion. Okay, so we can use that fact to find out certain information. So if quadrilateral ABCD is similar to quadrilateral WXYZ, find the measure of angle B, measure of angle Y, measure of angle D, and measure of angle Z. And here's our picture. Okay, so this is C, D, A, B. And this is X, W, Y, and Z. And this is a right angle, this is a right angle, this is 60, and this is 130. Okay, well, because angle X corresponds to angle B, then we know that measure of angle B equals measure of angle X. So that has to equal 60 degrees. Okay? And since C corresponds to Y, then Y must also be 130 degrees. So we know that measure of angle Y equals measure of angle C equals 130. And we know that the angles of a quadrilateral add up to 360 degrees. So we know measure of angle A plus measure of angle B plus measure of angle C plus measure of angle D has to equal 360. And we know that A is 90, B is 60, C is 130, and we don't know measure of angle D. And so we can solve for that, and so we get measure of angle D has to be 80 degrees. So therefore, measure of angle Z has to be 80 degrees because it corresponds. Okay. All right. Now we've also talked about that corresponding sides have to be in proportion if two polygons are similar. Okay. Well, the ratio of the lengths of the two corresponding sides is called a scale factor. And we say it's the ratio of the lengths of two corresponding sides. Okay? And so we can use the scale factor to find the length of unknown sides. Also, just a notation note, sometimes in order to make it easier to see what angles correspond to what angles, we name them by the same letter, but we put, for instance, if I have angle A corresponds to angle A, and we put a slash, and that's red, A prime. Meaning we just match up the A's, and that means those are corresponding angles. So for example, if I have this quadrilateral and this quadrilateral, and this is A, B, C, D, and this is A prime, meaning that angle corresponds to angle A. This is B prime, meaning it corresponds to angle B, C prime, and D prime. Okay, so we know exactly which angles correspond to which angles. So this is, this side is 24, this side is 27, this side is 30, this is y, this is 20, this is x, this is z, and this is 15. Okay, so we want to find a scale factor here. So to find a scale factor, we have to find corresponding sides that have values that we know. So for instance, side AB, we know that's 24, and that corresponds to A prime B prime, and we know that is 20. So we can set up a ratio of length of AB to length of A prime B prime, which would be 24 to 20. Those both reduce by 4, so this would be 6 to 5. So 6 to 5 is what we call our scale factor, because remember that all the sides are in the same proportion. So all the sides have to have a ratio of 6 to 5. So we use that fact to find the lengths of the sides. So let's say I want to find the length of x. Okay, now remember that order matters. So basically we're doing, this is the large to the small. Okay, so I use my scale factor 6 to 5, and then on the large side, the side that corresponds to x is BC. Okay, so I write a ratio of the corresponding sides, so 30 to x. And then I just use means and extremes to solve for that. So I do 6x equals 5 times 30, divide by 6. So x equals 5 times 5, or 25. So now we know that x has a length of 25. So we continue that process. So let's say I want to find y. Okay, so I still use my same scale factor because I'm using the same diagrams. But now y is DC, and that corresponds to D prime C prime. So I set up my ratio. So remember I did large to small. So it's going to be y on top, 15 on bottom. Order is super important. Now we use means and extremes. We get 5y equals 6 times 15. Divide by 5. So we get y equals 6 times 3, or 18. So now we know that y has a length of 18. And then the last one we need to find is z. So again, we use our scale factor, 6 to 5. And the side that corresponds to z is AD. And remembering I did large to small means the 27 goes on top, the z goes on bottom. So 6z equals 5 times 27, divide by 6. So z equals 45 over 2, because this reduces to 2, this reduces to 9, so 5 times 9 is 45 over 2. So again, the scale factor allows me to find the lengths of unknown sides. And again, the key idea is once you set up your scale factor, you have to keep the same order for all your ratios. So remember that I set it up as large to small, so all my ratios had to be large to small. I could have set it up as small to large. I still get the same answers, but all my ratios have to be flipped over then, okay? So let's look at one more example, okay? So let's say I have quadrilateral GEOM is similar to quadrilateral G prime, E prime, O prime, M prime. Okay? First of all, I want to find the scale factor. And I want to find the perimeter. So A, B, perimeter of GEOM, and C, perimeter of G prime, E prime, O prime, M prime. And here are pictures. So this is GEOM. This is 24, 21, 27, and 18. And then I have G prime, E prime, O prime, M prime, and this is 24. Okay, so first of all, the scale factor. So I have to find a side that I know the length of. So I'm going to do a ratio of GM to G prime M prime. Okay, so GM is 18 and G prime M prime is 24. So notice now I'm doing small to large. Okay, and this equals 3 goes into both of those, so that's 9 over 8. Okay, so oops, sorry about that. 6 goes into both of those. I don't know what I was thinking. 6 goes into both of those, so that is 3 over 4. Okay, then the perimeter of of G quadrilateral GEOM is 18 plus 24 plus 21 plus 27, so that gives us 90. And so I want to set up a ratio of the perimeters. Okay, so the perimeters are in a ratio of 1 to 1. So what I can do is I use my scale factor, and so the perimeter of the small one is 90, but I don't know the perimeter of the larger one. So I just set up a ratio or a proportion, and then 3x equals 4 times 90, divide by 3. So x equals 4 times 30, or 120. So the perimeter of G prime, E prime, O prime, M prime is 120.